Hello my dear students, my name is Avigyan Tiwari, working as assistant professor at SIT's Bhopal. So today we are going to see finite automata to regular expression. It means we are going to convert this finite automata to its equivalent regular expression. So there are two types of conversion in regular expression. So we can convert regular expression to finite automata and we can convert finite automata to regular expression. So here we are going to see finite automata to regular expression. So it means we'll have a finite automata and we'll have to convert it into its equivalent regular expression. Okay, so we'll see the lemmas, or you can say rule. So the first rule says that check input on all available states with their input providers. It means let me show you. It means what we have, we'll have to check the input providers. So let us suppose we have this two state. So if I'm talking about this state, so this state will be the input provider. So for this state we have two input providers. The first one is this one, and suppose for this input B input, it is going to be our input provider for this one, and this will become a second input provider. So we have two input providers for this one. Okay, so we'll have to check it first, then add epsilon input directly in initial state. So why we are including epsilon in the initial state? The reason is that very simple. Try to understand this one. So if this is our initial state, if we are giving any kind of input or whether we are not giving any kind of input, it doesn't matter. We are in initial state itself. So whatever be the finite automata we are going to see, if we are going to give any kind of input, if we are not providing any kind of input, it doesn't matter. We are in initial state itself, and that's why we are adding this epsilon in initial state. We'll see later in more detail. Okay. So, and we'll have to try, the third rule says we'll have to try to form Arden's equation. If you don't know about Arden's equation, please go and see the identities. It says if we have an equation like this one, so we are going to write directly this one. So this Q plus RP will be get replaced by this QP asterisk. Okay. So please go and see the identities. So this is the meaning of Arden's equation. So Arden's equation plays a vital role while converting a finite automata to regular expression. And remember this P will not going to be a get epsilon value. Remember this one. This P is not going to get epsilon value. The fourth rule says that we'll have to try to convert all the equation in the form of Arden's equation or Arden's format. Okay, so whether you are using substitution method or any other technique, we'll have to try to form the equation in this Arden's format. Okay, and the final answer will be given by the final state. So we'll have to solve the equation for the final state. Always remember this one. Okay. So if we have more than one final state, so we'll have to take the association of all the regular expressions which contains the final state. Okay, and last but not the least, the regular expression must be the equivalent of that finite automata which is given here. So remember this one, the finite automata and the regular expression must be an equivalent of each other. So the regular expression which we are converting right now, it must be equivalent of that finite automata. It means we are not able to change the meaning of this finite automata. We'll have to take care of that one. So let's take an example. So this is a finite automata which is given to us. So we have only one input provider which comes from Q0. Okay, and for input A, it is going to Q0 itself. Okay, so we are considering this only Q0 because we have a single state. So this is the initial and this is the final. So we have a Q0, so we are going to write the equation for this Q0. because this is an initial state, so we'll have to add epsilon. Whether we are providing any input or not, we are in this state itself. That's why we have added this epsilon. Plus the input provider is Q0 and for the input A, and that's why we have written this one. So if you see this equation, it is in the form of this one. So this will become R, this is Q, and this is plus RP. So you can write QP asterisk. So QP asterisk is what? QP asterisk. You can write directly QP asterisk. So Q is what? Q is this one, and this is P. Okay, so it is written here. You can see from here itself. So we can write QP asterisk. So we have this equation. Okay, and by seeing identities, you can know identity means rules. It is already declared that epsilon and A asterisk is going to give you A asterisk. So remember this one, and it is what it is written. A asterisk means it is going to accept epsilon or any combination of A. Let's see, here it is also possible. If we will not give any input, we are in Q0 and it is going to be accepted by this one. And if we provide only one A, it is going to accept 2A, 3A. So this is the finite automata, and its equivalent regular expression is here. We'll see one more example. Okay, so this is what we have, medium level questions. So we have two states here. So as many states we have that much of equation. Remember that one. And we know if we have two states, two equation, and if we have to solve for this Q0 and Q1. So two equation, two variable, it can be solved very easily. Okay, so let's try to understand this. Q0 is having no incoming edges. Okay, so it is having no incoming edges. So in Q0 we are going to write only epsilon, because epsilon we have to read. Whether we are giving any input or not, we are in this Q0 state itself. Okay, what about this Q1? In this Q1 we have two input providers. One is Q0 for B input, so that's we have written here, and one is from Q1 itself, so for B input, so we have this one. Okay, so now we'll have to solve this equation for Q1, because Q1 is the final state and we need equation for this one. Okay, so this is Q1 equal to Q0 QB. So okay, so for Q0 we are going to provide this epsilon here. So epsilon is, we put this equation. This is what we called substitution method. So Q0 value we are going to put here itself. So we have this one. So we know this epsilon and B by using the rules or identities. We know we are going to get this B itself. Okay, so epsilon B is going to give you B. And if you see this equation keenly, we came to across this one, that this is an P equal to Q plus RP. Okay, so this is Q and this is P. So QP asterisk you can write. So this is BB asterisk, and BB asterisk can be written as B plus. So for that you can see the identities. Okay, if you don't see the identities, you can prove here itself. So for B in the form of language you can write only single B, and for B asterisk what we have this epsilon, B, BB, and all the combination of B we are going to get. So it will goes like this one. If you open the bracket, you are going to get that again, B epsilon, BB, triple B, and so on and so on. So try to understand this one. Again, this epsilon B can be written as B, so you can write this B and BB and all the combination of B. We are going to get all the combination of B. So what does it mean? It means we are going to get the infinite B, and this is nothing. This is, you can write B plus. So at least one B is required. So here, what of this? See the finite automata. At least one B is required to accept the string. So you can say this is the equivalent regular expression for this given finite automata. Hope you understood this one. Again, a big thanks from my side for watching this video. Stay tuned and keep learning. Thanks.